Well, okay. All right. We are live. Let's go get everything set up here and we'll get our day started and do a job hunt. Day. Today is going to be day 10 of our adventure here. It's finishing up, I'm just going to say EDA part 3 and pivot tables. Real quick, we have this. This was canceled. I got a notice that it was canceled yesterday. So I'm gonna just delete that. I don't think there's a way to like remove it from Google Calendar. So do that. And while I'm starting this, let me get the chat situated here as well. Need to go into my window chat here. Bear with me 1 second. I got to take the copy current address. That's what I got to do. Copy current address, and then the pop out is that, and then you do that, and then so we should get chat popping up. There it is. Okay, I just need to interact with this and pop up the live chat. Okay, live chat there, and it says sign into chat. That's okay though. I think what I'm going to do. Can I say learn more? I don't want to do that. Can I hide that? Okay, what I'm actually going to do with this is trim that bottom there while I have this open. And let's see, we want to crop. So I'm going to crop the bottom of that to be, let's see. Yeah, what do I want? What do I want it to do? Okay, so the bottom needs to come up, let's say 90, 190. U10. I just want to get rid of that one thing there. 200. Nice round number. Let's do that, and then I'll just drag it down to be on top of here. Oh, it's not a nice round. I'll just do 210, actually. And then actually, let's go from the bottom, the bottom right, the bottom right. Go to the bottom right here, and so we want to go all the way to 1920, and we want to go from the. Oh, weird. Okay, so yeah, 1080, so it would be like 1050 or something. Or 1030, right? Okay, 1030. There we go. 1030 pixels. There we go. And so that's situated there. The chat is right there, and we're going to go and get started here. And so if I'm down here, chat comes up. If I'm up somewhere else, it goes and gets tucked behind there. So that's pretty nice. Let's see. What I'm doing here. I got my blue sky. Got my practical statistics for data scientists. Today we're going to explore 2 or more variables. We finished the correlation part of this yesterday. It was nice. Learned a little bit about R with this type of plot here, correlation plots with the matrix using the library core plot. And those ellipses kind of indicate the strength of the relationship and the direction of the relationship as well. So an interesting visualization. You can do a similar thing in Python with heat map, which is that's what I'm familiar with. The Seaborn library has that, which is good. So yeah, I'm gonna switch my side to live chat and I'm gonna get going. So, how has everyone been doing? I'm gonna actually let me do a couple more housekeeping things here. But before I yeah, well, let me just do that. Um ba-ba-da-ba-da-ba-ba-ba. Uh, 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 uh. Okay, so we gotta go to live. We gotta get the current live link. I'll put that up in there. And then I'll put a 10 here. And the theme of today, EDA, part 3, and pivot tables, just the title. Just the title from there. And let me do some more housekeeping here. Just get this into the chat. Go ahead and check me out at LinkedIn, where we act professional, right? Because we're professionals there. And part of being a professional is to have some backbone, right? And so lots of people on there have been not calling out what Musk did, and really just making a lot of apologies, just trying to well, maybe he wasn't a Nazi salute. It was a Nazi salute. So I'm going to read this article and see. A lot of I've been following the discourse. This has a lot of my thoughts, I think, in here. And this article is by Jeremy Fassler. It's on Medium. .com. So I'll copy the URL. I'll put the URL right in the chat there. So I'm going to go ahead and read this. And just to be clear, I loathe Elon Musk from the past couple the past 10 years. He's just been slipping further and further into right-wing nonsense. The anti-woke discourse and the anti-trans, just more and more he's been slipping into that, right? So you have to take that into context. When you're seeing him do this salute here, and to note that his personality, when he goes on Twitter, a lot of what he does is to troll people, is to make sarcastic comments and use that old that meme where basically you imagine him being the person in that meme where they say joke's on you, I was just pretending to be the R word. And yeah, he gives off that, and that's what he gives off. So if you're not in tune with that, you're doing your own thing. You're doing, you're focusing on your career. You're focusing on stuff. You're blocking out all this other stuff, right? You haven't seen that. You haven't seen that part. So seeing him do this, you might apologize. You might say, well, maybe it wasn't. Maybe he was just maybe it was just a mistake. Maybe he didn't mean to do that. He totally meant to do that. Whether or not he literally believes that the in Nazism is kind of beside the point. And you have a lot of people who are kind of saying, well, he can't be a Nazi because he's not these things. He can't be a Nazi because he's... No, that's not what anyone was saying. They're saying that there's a lot of parallels here. And let's see. I just can't let this slide. I have to say something about this. So let's read this article. Shortly after President Trump's swearing in yesterday, Elon Musk made the Nazi salute, aka the fascist salute, in front of a packed audience at Washington, D.C.'s Capital One Arena. Here's the video. So the video is not linked in here. Let me see if I have the video linked over here. I think I can copy it and put it in there. Copy video address. Oh, you used to be able to. I don't want to have X on there, so I'm just going to copy. Yeah, I'm not going to use any X links. Yeah, not doing that. Not doing that. Let's not drive anything to his site. But okay, so let me read that though. Oops. All right, I'll just go to the Medium article and we'll do that. Do it there. Okay, it's gonna load up the video. And so they show the video. So I'm not gonna play it. Actually, I will play it. I don't want to send.
Thank you for making it happen.
It's fine to use his resources. That's fine, I guess. Let me watch it again. So.
And I just want to say thank you for making it happen. Thank you.
Salutes the crowd, turns around, and then does it again towards Donald Trump. So this was the thing that Nazis used to do. They salute the crowd. They salute Hitler. This statement should not be controversial. We saw Musk do it before our own eyes. This isn't the Zapruder film. No detailed analysis is necessary. This is Elon Musk, the man who effectively purchased the presidency of the United States for his friend Donald Trump, saluting his leader in the same manner that the Nazis saluted theirs. Right arm raised up. End of story. Except it's not, because in today's bifurcated reality, you can hold an apple in your hand and some will insist that it's really an orange. Unfortunately, many of the It's an Orange crowd are journalists who have given Musk a benefit of the doubt he doesn't deserve, whether they're doing so out of a desire to be objective or because they're politically right-wing is less important than the fact they're doing it at all. And their reasons for doing it all fail to pass muster. One apology was Elon Musk has Asperger's, autism. Nobody... how come there are millions of autists who don't go making this salute? Like, what's going on there? Why are you using autism as an excuse? As a person with a strong so this is Batya Unger Sargon. As a person with strong track record of criticizing Elon Musk, I feel extremely confident asserting that this was not a Nazi salute. Elon Musk is a friend to the Jews. This is a man with Asperger's exuberantly throwing his heart to the crowd. We don't need to invent outrage. This defense pops up often when men are accused of bad behavior. Yes, Musk has talked about having Asperger's, a neurological condition closely associated with autism, but I know plenty of people who either have Asperger's or are spectrum adjacent, and none of them ever made a Nazi salute, period. Then the second apology was, it's the Roman salute. Weirdly, I've never been caught making a gesture that people had to debate being a Nazi salute or not. Guess I'm just built different. So funny, Musk's gesture was indeed pretty much the Roman salute. But I'm sure if cameras were filming and photographing you all the time, I'm sure someone could potentially find something, quote, controversial, end quote. Some history is necessary to explain why calling it the Roman salute keeps Musk's gesture at a historical remove. The idea of a Roman salute is an anachronism because the Romans never did it. No Latin art, literature, or historians have ever described them as raising their arm outward in deference. Orson Welles blamed Cecil D. DeMille for inventing it, but although the salute appears in the silent film epics of the 1910s, he gave DeMille too much credit. If Welles had done his research, and it's no surprise he didn't, he'd know that the earliest known artistic depiction of the Roman salute appeared in 1784 when the French artist Jacques-Louis David painted Oath of the Horatii, which depicts three brothers pledging to fight for Rome. The painting shows the three brothers doing a version of the salute before their father, who holds a group of swords. Fascists who obsessively adopt the trappings of a mythological past to justify their present actions glommed onto this gesture in the 1920s, most notably Mussolini's brown shirts and the Nazis. Even a painting depicting something that, if it did happen, did not look anything like how David portrayed it, was justification enough for it to gain traction. And then a third apology was, it was just an awkward gesture. And this is one of the most bizarre ones, except maybe not, because the way the ADL has been treating protests around Gaza as conflating anti-Zionism with anti-Semitism. The ADL put out this statement: "This is a delicate moment. It's a new day, and yet so many are on edge. Our politics are inflamed, and social media only adds to the anxiety." It seems that Elon Musk made an awkward gesture in a moment of enthusiasm. Not a Nazi salute, but again, we appreciate that people are on. So I have actually on Blue Sky, I have the other one. I don't think that I can actually load this up. I don't really want to drive traffic here, but okay, there we go. The only time I'm going to drive traffic to X. Again, we appreciate that people are on edge. In this moment, all sides should give one another a bit of grace, perhaps even the benefit of the doubt, and take a breath. This is a new beginning. Let's hope for healing and work toward unity in the months and years ahead. The same ADL who wanted to jail Palestine protesters. Yeah. To call it an awkward gesture deliberately robs the image of its context. Musk, whose website has been overrun with Nazis since he bought it, appeared at a rally for a man who once said Hitler did a lot of good things, and made a movement historically associated with the Nazi Party. But it was just an awkward gesture, according to the ADL. The ADL may not be a journalistic organization, but as far as spreaders of misinformation go, they are among the worst. Jews have spoken out against them for years over the way it conflates all criticism of Israel with anti-Semitism. So this explanation proves they are morally derelict when it comes to combating actual anti-Semitism. Imagine their response if Musk had said "Free Palestine." 4. It only appeared to be a fascist salute, which again is maybe just an awkward gesture, right? Billionaire Elon Musk gave what appeared to be a fascist. So, yeah, this is the hedging that goes on in journalism now. They don't want to get sued. Can't accuse him of making a fascist salute when he absolutely did. Billionaire Elon Musk gave what appeared to be a fascist salute Monday while making a speech at the post-inauguration celebration for President Donald Trump at the Capital One Arena. Okay, I'm not going to click through there. It's not inherently wrong to give people plausible deniability. In fact, we should all kind of lean towards giving people the benefit of the doubt, right? But as I said before, we know who Elon Musk is. We know the beliefs he's expressed. This is in line with that, especially when you plan to write about something making a heinous gesture, but the use of the word appears feels weak when applied here. Given that PBS is a government-funded entity, some caution on their part may be justified, but they're not the only ones. Here's The Guardian doing the same thing. Elon Musk appears to make back-to-back fascist salutes at inauguration rally. Appears to. The Anti-Defamation League, which campaigns against anti-Semitism, defines the Nazi salute as raising an outstretched right arm with the palm down. Yeah. Right, so we don't have the Israeli newspaper there, but I guess it's the same thing. Appears to give. The Washington Post didn't even bother to comment on the gesture, calling Musk's speech exuberant in the headline and cutting away from the moment he raises his arms up. How the Washington Post is covering Musk's speech down here. Yeah, I didn't even really look at it. Elon Musk gives exuberant speech at inauguration. And just this morning, and just remember when Howard Dean got canceled from his campaign because he his mic was too loud, and he gave a weird and that was enough to cancel him. The fuck. And this is Jeff Gutenberg parenthesis Jarvis on X. Cancel all doubt. Walter Isaacson is pure Musk apologist on Morning Joe. Obviously, he did not intend it to be a Nazi salute any more than I don't think, say, Donald Trump intended not to put his hand on the Bible. I'm sure he didn't intend it to be a Nazi salute. None of these entities are government funded, and even they're falling into the same trap that PBS did. Couching their language to give someone a benefit of the doubt that he is made clear he does not deserve. The man made the Nazi salute, and to offer any plausible deniability means he and his followers can use that doubt, turn it against us, accusing us of overreacting or reading into things that aren't there. If journalists are to report on this administration accurately, they will have to acknowledge that this is, in this new reality, there can be no hedging stories with inadequate wishy-washy language. The old rules no longer apply. To quote Oliver Stone's JFK, we're through the looking glass here, up is down and black is white. I'm taking a break. I'll be back in a minute. Okay. So let's get started with this here. I'm a little fired up today. As if you couldn't tell. But actually, I think I'm going to take another break. I really just need to get started here. I'm just infuriated by that. It's just... it's the sign of the times, if there's anything like would be more fitting there. This is like the same thing as alternative facts. We're spinning out alternative facts again. Remember the first couple days of the first Trump admin? Alternative facts. We're just, spinning them out again. And the journalists and Large media entities are supporting it, are putting out those alternative facts. They're full on in on alternative facts. Okay. But, okay. Deep breaths. How can we confront these alternative facts? Let's get some real facts, things we can use against this nonsense. Statistical evidence, numbers and data, and some charts. All right, so today we're going to explore two or more variables, familiar estimators like mean and mean. Okay, actually, let me get over to, need to do one other thing just to get my context back up here. If I go over to code, there we go. Now I have everything I need. Okay, so I'm going to start a focus session. Hypatia is asleep on the couch. That's good. I have to keep an eye out for when she wakes up. She's going to need to go outside. So we have everything set up from yesterday. Still up and loaded. Actually, where did my I think I somehow closed the VS Code though. I don't know why that's not up. Let me check my processes and see if that's open. No? Really? Oh, it was acting funny. That's right. It was acting funny, and that's why I closed it. So I'm just going to go back over to here, and I'm going to go, let's just click that one again, and we'll do that. All right. Whoopsie-doopsie. I can't open it because it's not found. That's my TikTok data. I don't know why that was open. Well, why is that open? That's weird, isn't it? Put that up in there. Yeah, okay, that was weird. Right. Okay, that's the last thing I had open. I deleted my TikTok account for Data Cross Puzzles. I'm not sticking around for that. I downloaded the data with the links, but I think I have all my raw video files. They don't ever give you the video files. You have to download those like individually, so it's a pain in the ass. But let's go ahead and open up these two workbooks here. We have an R Markdown notebook and we have the IPython notebook. And we got to start a new chapter in here, right? So let's get that up on here. Not a new chapter, but a new section within within here. Exploring two or more variables. Familiar estimators like mean and variance look at variables one at a time. Univariate analysis, right? That's what we've been looking at there with mean and variance and standard deviation, those estimators, right? Correlation analysis is what we did in the last section, is an important method that compares two variables that are bivariate analysis. Let's go ahead and highlight this as key terms here because sounds good. And then in this section, we're going to look at additional estimates and plots and at more than two variables multivariate analysis. And actually, I think what I want to do is to make a note of that right here rather than having it in my what do you call it, in the annotations. Let's bring it into this daily note and say what univariate analysis is. And actually, you know what? I'm trying to think of like whether or not I should have an individual note for each one: univariate analysis, bivariate analysis, and multivariate analysis. Yeah, I think I want individual ones. Univariate analysis, we'll just get um, statistics, data science, statistics, and we can do analytics, data analytics. There we go. Those are the ones, and I'll just like go ahead and copy this and paste it over to the other thing. So I'll just do like estimators. We'll just do like mean. Variance. That'll be an idea to put there. Okay. And let's go ahead and copy this. Make a new copy, and then we'll just do bivariate analysis. And so this compares two variables. Univariate estimates one, right? One at a time. And bivariate variable is going to be, let's see, correlation. So we want to say correlation and an important method that compares that. And then we're going to do, in this section, we're going to do multivariate analysis. So let's go ahead and do a copy. This one, copy current file. I should get that in like a hotkey. Multivariate analysis, and we'll do two variables, and then let's say estimates and plots. Okay, so we'll flesh out what this means, I think, throughout the course of this day. Give univariate analysis and that. So what I'll do is I'll do the resources for here. Oops, and we'll do bivariate, multivariate analysis. And we'll just move this into our job notes. Should really just have that automatically go up, but no, actually, I don't know what I'm talking about. It's going to be there. Day 10, we have to move this one to days for job hunt, and we'll do that. Okay, let's see. In this section, we look at that. Okay, so key terms for exploring two or more variables. So under a multivariate analysis, what do we do here? Look at some terms. So we'll say contingency table. I think I'm not sure. Plot. I kind of want these to be their own notes for some reason. Like I just do. I might want to come back to these notes and flesh them out more. Like if I have to do a contour plot or something later on, I will be able to like refer back to my notes on these things. So let's go ahead and create those and contingency table. I guess what I'll do is I'll just copy the tags. Oops. There we go. Okay, this is a tally of counts two or more categorical variables. What I'm thinking for these notes, I think like what I'll have is like examples, and then I'll have like definition. And that, okay. Yeah. Okay. Then from here, I'll just do a similar thing where I'll just like make a copy of the file, and then from here we'll just do hexagonal binning again. And then we'll do this is a plot of two numeric variables with the records binned into hexagons. Okay. And then we'll just do this and make a copy of that file again, and then we'll get the contour plot. A plot showing the density of two numeric variables, like a topographical map. You got to define that then. It's kind of not a complete definition there. Or it's just an example, actually, really. It's showing the density. So, for example, a topographical map. Make a copy here. And we'll do a violin plot. And this is I'll just say plot. Something like that. So Art is pretty good violin plots from my from what I remember. I'm gonna actually just move these to job notes. Job notes, and we'll close that one. Job notes. Oops. And we'll close that one and move this one to job notes and close this one. Oops. Close that one, and then multivariable analysis, I think we have already there, right? Yeah. Yeah, it's already in there. Okay. So we have all those. Let's get all those other things here. So we have contingency table. That's what we talk about here. We talk about hexagonal binning. We do contour plot. And a violin plot. Okay. Oh. I bet that rant like really tanked my discoverability. That'd be pretty funny. Well, nobody's gonna find me now. Except for the Nazis, maybe. Okay. So, like univariate analysis, bivariate analysis involves both computing summary statistics and producing visual displays, and the appropriate type of bivariate or multivariable analysis depends on the nature of the data, numeric versus categorical. All right, right. So let's try to recap Univariate analysis, you're trying to infer the mean and the variance, right, from a sample of data. You're trying to infer the population mean and the population variance. That is, with that univariate analysis. Bivariate analysis is for doing relationships between two variables. So if you're looking at the correlation, you're looking at the covariance. So between any two, so like what do they usually call that? Pairwise relationships was what we were looking at with correlation. Multivariate analysis is going to involve multiple features affecting one other variable, which is going to be the target. Right. So that's very important stuff, right? So let's see, hexagonal binning and contours. So let's get into that. Let's go ahead and create another markdown here, hexagonal binning and contours. Okay. Actually, while I'm doing this, let me write down like what we did here today. So what we're going to do. So the concepts that we do here today. And then I'll link these later. So hexagonal binning and contours. And this is plotting numeric versus numeric data. Right. Two categorical variables, which is different. I did some of that work in Lambda when I was doing the labs portion. Nobody believed me that you shouldn't use correlation on categorical variables. And I felt like I was going insane. They put me on the spot and was like, well, why can't you do that? Why can't you? And then another guy was like, well, you can do this then, and you can do that. I'm like, you could do that. That won't really help. And it's like, yeah. Yeah. Okay. Hexagonal binning and contours. We got to get the same thing up over here. So we have those notes in place. It's always good to kind of like start the day with like a plan of, what you're going to do. An overview of like what you plan to do, right? I guess that's the intention. And then I find it like helpful for me to like prime my brain for like these are the things we're going to be talking about. So I can like just kind of like behind the scenes inside the subconscious, we have the connections being made. Now that we brought up these words, the brain's like, it's heard that word before. It's connected to something else. I don't know. It's very weakly connected in neuron to neuron, but gonna bring it to the forefront. Let's see. We got hexagonal binning, and we have exploring two or more variables. Actually, let me do this so that I have that note there too. There we go. There we go. There we go. Okay, so now I can just refer back to this. Two or more variables. I wonder if anybody is working on like a way to integrate notebooks with Obsidian. If you are, please let me know. I would love to try out some beta cases of that and help you develop that. Scatter plots are fine when there is a relatively small number of data values, right? They can get very crowded. Like even after this one, which only has 700 something, you have to like, it gets very clustered, very clunky. Involves only about 750 points, right? And so for data sets with hundreds of thousands or millions of records, a scatter plot will definitely be too dense. So we need a different way to visualize the relationship. To illustrate, consider the dataset KC tax, which contains the tax-assessed values for residential properties in King County, Washington, in order to focus on the main part of the data. We strip out the very expensive and very small or large residences using the subset function. So we're going to have to go ahead and curl that data set. Go find out where it is located. I'll just search through here. KC dataset, KC tax. Oh, you have to download it and then unzip it. Okay. Again, with the downloading and the unzipping. KC tax. Okay. Fun. It must be because it's big. I guess I'll just download it from here. Let's go ahead and download raw file. And then from the thing here, we'll just unpack it with gzip. So let's just get that reference so that I don't have to go crazy trying to remember the syntax here. Gzip data, and it's going to be the KC something or other, right? KC tax. Oh, I have it right there. Let's see. KC tax. CSV. That. Do that. That is unzipped now. I can comment that out so I don't run it again. No need to unzip something that's not there anymore. And let's go ahead and get the... I thought there was another one. Wasn't there another one? KC tax. No, I guess not. Okay. Now I'm all confused. There we are. Okay, so we're going to look for King County. That's what KC is. It's not Kansas City, apparently. It's King County, Washington. In order to focus on the main part of the data, we strip out very expensive and very large, very small or large residences using the subset function. So we'll do this using that as well. I'm going to do the pandas way first. So let's do KC tax 0, strange name for a data set here, or a data frame, but that's what we're going with. And this is definitely somebody who programs in R first and doesn't do, Python as an afterthought. Maybe that's why GetEck is part of this. Brought along the Python code, maybe. Whereas the original, or the first edition was only, let's see, was only in R, and then the Python. What? I'm very confused. So this is stripping out stuff, but we do need to load the data set in, right? So KC X is going to be equal to the pandas read CSV, right? And we're just going to take the data tctax.csv. There we go. I don't know. I had a thought going, and I think I just floated off from it. So apologies. You're gonna have to deal with my stream of consciousness for today. AC tax dot square foot to living total living square foot total living area. If it's less than 3,500. Oh my gosh, what are you guys living in mansions here? 3,500 square feet. Who has that kind of space? I certainly don't. Let's take a look at the shape. PD is not defined because PD is on the run. PD don't care. Let's run all because the pandas is somewhere imported up above, and I don't really care about trying to track it down the individual. Yeah, the individual cell that runs that, so don't want to go after it. Okie dokie. Well, while that is going, let's go ahead and try to do some of the code for R. And if my fingers can work today, I might be able to type this out. Got to do some finger stretches. Ooh, very tense. Very tense indeed. Very tense. Okay. No, how did I lose this here? Bop, bop, ba-na, ba-na. And that sucks. I really thought that it would have the things that I brought over there into there. Okay. Okay, is this done now? Okay, so yes, the shape is 432,693 rows, and there are 3 columns. So lots of records, not a lot of things here. So I guess we're just looking at how one variable is affected by 2 others. I'm going to take a quick break, actually. I need to take care of some things, and I'll be right back. Okay. So I got to read in the CSV for the KC tax. And now we got to, so we're doing the, what do you call it? The R version of this here. Subsets. Using the subset function. So subset. I should read Kieran Healy's book again. That was really helpful in learning R. So we have similar syntax here to pandas with this subset function here. And then you just taking a look at how many rows there are. Oops, sorry. Man, okay, so what are we doing? We got to look at, can you do end call? See if that works. Knit this document, and there's an error. Is there an error? Unnamed chunk. The thing about our markdown notebooks is that it takes a while to like knit the entire document once you like have like a pretty big document. So it's hard to like do this like interactively. So especially in VS Code in uh-oh. Oh, there it is. Okay. In our studio, it's much more easily integrated. Like you get your figures and stuff available to you there. So endcall is a function as well. Okay then. So there we go. Cool. Pretty cool. Pretty cool. So we have our data loaded up. Let's take a look at what we can do with this. So hexagonal binning plot of the relationship between the finished square feet and the tax assessed value for homes. So we have those columns in there. Let's take a look at that, actually. Let's take a look at KC tax 0.head. And we'll take a look at what we have. We have tax assessed value. We have square foot total living and zip code. So all of these data sets are neat little data sets, right? They've already been cleaned and wrangled. So you don't have to do anything with them to clean them up, which is nice, but still taking a long time to get through this. So we're gonna take a look at ggplot now. Okay, so I think I have to install that though, don't I? We'll see. We'll see if we need to. See if we need to do that. ggplot. KC tax 0. The AES. What was the AES thing again? I forget what that was. That was used a lot in Kieran Healy's daily data visualization book. A really good book. Looking like I should really go over that one again to get a handle on ggplot, or if I want to get a handle on ggplot. So it's the grammar of graphics, and you create like this ggplot object, right? And then you add onto it. It's like you get to like add layers onto it from the after you create the object. So it's very similar to matplotlib in the sense that with matplotlib you create figure and axis handles, which are the objects that you then work on, and then you can build and put axes on top of them, and you can put figures on top of them. Here, you're just building one object. You're just building a ggplot object, and then you're going to layer on things on top of that There's also like when you create the ggplot object, you're going to maybe like specify whether or not you want to have multiple subplots inside of there and whatnot. I have not touched that in a while, but I'm assuming that we're going to get to that by the end of this chapter here. Let's see here. Theme, black and white. Not black and yellow. Scale, fill, gradient. So these are all just things that add on to the ggplot object. Labs. X is equal to finished square feet. Yeah, labs is going to be the labels, right? You can add labels. I forget who, they're pretty big name, or some pretty big names in our programming space that were behind the development of ggplot. I want to say, what was his name? Peterson or something like that. Yeah, I don't think ggplot. I think I have to install it. And let me just go before I even like waste time on trying to knit a document that's going to fail. Let's take a look if we need to import it. So to import it, we need library ggplot2. So we might need to install that. So before we go ahead and do that, let's do interactive R shell here, and we're gonna do an install packages for ggplot2, and it's gonna ask me which mirror to choose. It always asks me that every single time. I don't know if there's a way to set up a default for that, some kind of configuration file or something. But there we go. Okay, it does seem like we needed to download some stuff for ggplot. Okay. Okay. There. Here we go. I'll actually like shrink this a little bit. We don't need all of that, right? We don't need all that space. Let's shrink it to here, and then what I'll do is I'll move this over. Get rid of some of those margins. And actually margins right there. And then that looks good. And I can move this over to here. This should be like connected to there, but it's not. That looks pretty good, I think. I think it looks pretty good. So then let's go ahead and knit this document. I'm going to use Control-Shift-V on mine. And then there's just or Control-Shift-K. That's the button to click to knit the document. And just continue adding onto our document from Exploratory Data Analysis. These are just little code snippets that were found in the book. Okay. And what are you going to do there? So let's see. Did we get that? Hexagonal binning. Did it knit properly? Package hex bin is required to stat. Okay, caused by compute group error. So we need stat bin hex. So apparently there's another package you need. Okay, but we're gonna need bioplot as well. We didn't do tidyr or dplyr. That's weird. Okay. Or actually, no. What is the hex bin package? R. Why didn't it? I guess it didn't download all of the dependencies when we did that. So let's go down to here. So we're going to install hex bin packages, and looks like that's loaded now. I can try to knit it again and see if this will work. Okay. Rather than plotting the points which would appear as monolithic dark cloud, we grouped the records into hexagonal bins and plotted the hexagons with a color indicating the number of records in that bin. Okay, so let's take a look at that chart once we do that. Let's see if it's ready to go. There we go. That looks like hexagonal bins. Certainly does, doesn't it? Move this up a little bit. Okay, let's zoom in on this. Okay, so we're going to take a look at this chart here. So the hexagonal binning plot of the relationship between the finished square feet on the x-axis here and the tax assessed value up there. And let me try to lock this in right here. Just remember that the what do you call it? The finished square feet is on the bottom there. Okay. So rather than plotting points which would appear as a monolithic dark cloud, we group the records into hexagonal bins and plotted the hexagons with a color indicating the number of records in that bin. Interesting. So it's like a it's like a histogram, but rather than just being the count being given by one variable, the count is given by two variables. Plotted the hexagons with a color indicating the number of records in that bin, and in this chart, the positive relationship between square feet and tax assessed value is clear. As you go into this regime here, this little elliptical area here, you have square feet and tax assessed value. Most of those records are right in that region there. Okay. Interesting. Interesting. That's an interesting way to look at that, isn't it? Um, so like right off the bat, rather than okay, without even knowing, like, I like so like we could have done a scatter plot and then did the line of best fit through that scatter plot. It wouldn't be a very strong correlation, but there definitely is something here, right? It does look like there's a signal here that in this like one region there's a lot more records in that region, and you might not notice that when in fact you probably would not notice that if you just did the line plot, if you just did the scatter plot with a line of best fit going through it. Probably wouldn't catch this. You would see that maybe you'd have this line that goes through. It might be tugged by some outliers up at the top, so it would probably distort the line. And you wouldn't catch this here. Interesting. That's an interesting plot then. Okay, so let's see. In this chart, the positive relationship between square feet and tax assessed value is clear, right? As you increase square feet, the tax assessed value goes up, at least like in this regime here. And even overall, like you kind of see like different kind of areas within here that are shaded darker in there. Seems to be like more than just one line of best fit, like a couple different ones for a certain tax assessed value. So then an interesting feature of the hint of additional bands above the main band at the bottom, which is the darkest band, indicating homes that have the same square footage in the main band. Um, but a higher tax assessed value. Right. So if we're in this main band, we have like another bracket up here. There's another like band up there and then another band up there. So like just hop on up there. Yeah, like you can kind of vaguely see them. There's like this one here. There's maybe a weaker one there. There might be like one down here, and then there's the main band there. The reason why I say there might be one here is like this could just be maybe noise. And we have like areas right here where we have same square footage, but higher value. Okay. Cool. So that looks like it's pretty good here. Let's try to do this same plot um, in pandas. So we're going to create an axis handle. We're going to take our data frame and we're going to use plot a hex bin. So I think is that now core pandas? Is that vanilla pandas? We don't need to import anything to extend that functionality, functionability. Create a grid size. Interesting. So this is how you create the number of bins here. Is probably the the analogy between histogram and the hexagonal binning. So this is the first time I'm actually hearing about hexagonal binning and these hex bin plots. So this is me learning as I go here. Let's see if this works. Yeah, it does. Look at that. All right, let's take a oh, I forgot to zoom out of that. So the code was up here. I just entered that in. Excuse me. And this is what we get. Same kind of thing. You can actually maybe see the relationships a little bit clearer here. We have the one band here, the second band there, and the third band there. A little bit harder to see in the black and white, right? Like if I come down here, a little bit different to view than to look at it from there. You can still see it, but for some reason, green just like kind of pops out better for me. At least for me. Maybe if you're like colorblind or have difficulty with green colors, might not see the same thing. But for me, it's like it's clear. It's great. Um, that's interesting to take that away from it. They actually changed the color here. I wonder if I could change the color with something. Yeah, they might like use Viridis or something. Yeah. I'm surprised all these plots are they're not in color. I wonder if there's like some default I could set or something like that. So interesting. And then so figure 9 uses contours overlaid into a scatter plot to visualize the relationship between two numeric. Okay, so we're looking at we're going to look at this one. We're going to have like this kind of maybe a density estimate here. Is that what's going on there? Contours. Oh no, the contours. Right. Topographic map. I'm gonna have to refresh my memory on those. They're like these are ISO something. So it's the areas of the same value of the predictor of the third of the thing that's kind of up above, right? If you imagine this plot like being in 3D, those contours being like a mountain, depicting a mountain. Those lines are points where the height, in the sense, right, is the same. And so you can use that analogy with anything that's like, uh, you know, plotted this way with two predictor variables and one target. With the z-axis being like your height. You think about how high or low the z value is. Okay. Woohoo. Shower. What does that mean? So we're going to make this plot. We're going to do some contour plots here. That's interesting. I think like we're going to probably take those points and then do some interpolation or something with that. That's what goes on probably underneath. So it's the kernel density estimation for two variables in one predictor, right? Okay. Let's go for the seaborn one first. So AX is equal to that. We're going to take a figure handle and get our KDE plot object from seaborn, and we're going to get our two variables. The X variable going to be the total living space, and then the Y variable, traditionally, is going to be the tax assessed value. Why does that look weird to me? Tax assessed. And we're going to take that figure handle. Oh, okay. So we're taking the previous plot, the previous plot's figure handle from here, AX. Taking this figure handle for this plot, we're going to overlay the kernel density plot. AX.set X label. Finished square feet. And we're going to label our axes here. And that. So I'm wondering if anybody if you find this after the fact, because very few people pop in here live. If you can let me know if you're following along with this with your own IDE or trying to recreate these things on your own computer, or if you're just following along. I'd like to know that. So this doesn't have that. The thing is, this isn't a good way to do this. What were the names? Tax assessed value. So it wasn't the right thing. So this is using. I'm going to make a comment on this notation. So Ruben Lerner actually has a video on this, talking about his arguments for doing using bracket notation in place of dot notation. You shouldn't use the dot notation for several reasons. One of which is that it's ambiguous. You could, if you have a column, if you have a column named index, well, you're finding the wrong thing, right? So you're allowed to have a column named index, Wait, what is going on here? Oh, I think I made a mistake here. Let me see something. Yeah, here we go. We're allowed to have a column named index. He says that, he understands that it looks kind of neat to have the dot syntax, but there's a drawback there in clarity, right? Because we're gonna have to use, and like that argument for me is really what sells me, is that you want consistency. Like, if there's a chance that I'm ever gonna have to not use the the column name, right? If you have like spaces in the name of your column, then the dot syntax isn't going to work, right? So might as well just stick to the bracket notation to access columns, to create series, right, from your data frame. Okay. So what am I missing here? Tax assessed. Assessed. That's why it looked weird. There are way too many S's. Okay, so KDE plot takes in only one positional argument, but we gave two. So I'm guessing that what we need to do is then use that as a, what do you call it? Oh, well, okay. I think we're gonna have to look up the errata for this. Let's look up the code here for the KDE plot. So we have to go data, and then X is equal to that, and then Y is equal to that. So the new, okay, so I think this is a thing with the updated version of Seaborn. So it is clearer to just say, KC tax 0. They're going with a sample here, which is interesting. So we're taking the data frame, KC tax 0. The next thing we're going to have is the name of the column, right? The name of the X variable, and then the name of the Y variable. And, okay, so it's not KC tax, it's with an underscore between KC and tax. And we'll just do this. So I think you can pass a series for the X and the Y, but yeah, maybe not, because I think you have to, like, when you define the data frame here, and you do the X value in that. Okay, this should work. Looks like it's calculating. It's probably might take a while, because in his example here, he's got 10,000 data points, and I'm not sure how many there were on this one. There was 400 and something, right? 400 something thousand. Yeah. So might take a minute, but in that time, we can take a look at how to calculate this, or create this plot in R. So we're going to use ggplots. We're going to take, let's see. What's the difference? I'm trying to figure out what the difference is. Oh, Hadley Wickham, right, is the ggplot2. What? Oh, okay. I was looking at the wrong thing. Okay. We need a different thing. KC tax 0. We're going to do the AES. What is the AES? You know what that is? Please let me know. I'm not good at R, and I'm just trying to like jog some memories here. And because I do need to take a course on the basics again. Like there's so many things that I'm not sure I can do with it either. So I'm not really don't have a good understanding of the libraries that you can use and stuff like that, especially with built-in. The thing that really frustrates me with R is that like everything has to be um, I guess same thing with Python. I guess I'm just more familiar with the standard library in Python than I am with R. Second, I'm trying to figure something out here. Okay. And then is that the plot? Is that what we're going with? Save that, and then we'll knit that document, and then we'll see what we can do here. Get that out of the way, and let's go back over here and see. It's 3 minutes later, and it's still churning away. But at the end of this, we should have a pretty nice looking graph here, right? Okay. I'm amazed that they didn't do this. So there is an error here. I want to just like take this time while I'm waiting for this to process to go over to the GitHub for this and see if there's any commentary on this page or this errata for page 38, this hexagonal binning, right? So let's go over here and we'll go issues. And we want to look at like past issues as well. So we'll look at like closed. And we'll look at ADE plot. Look for that. No thing there. So then we'll look for things that are merged or something like that. No. Okay, maybe I'll just like, yeah, okay, chi-square resampling pull request. Okay. Okay, so here's somebody who has a pull request then. Break down the chapter in Python into smaller files. Okay, well that's interesting. And this is still churning away, so I'm not sure. Like maybe I want to stop it and then go back. But hurry up, shit. Let's go back. There. Wait a minute. Am I? Yeah, I want to come here to the code. Where's the code? We want to take a look at the commits actually. Can I look in the commits? See the ADE plot? Two-dimensional extension of the density plot. Calculation of 2D. Let's just go to this. Can I take a look at that file? I have that file open already. But, okay, so he made a hex bin separate thing. Facet grid. Might be coming up here. Cross tabs. Gonna talk about cross tabs when we do the pivot tables later. Yeah. Maybe we'll get to them early. PLT tight layout. Okay. Huh. Yeah, I mean, he's just using KDE plot there. So let's see if this works here. That's still going. Really? Let's cancel that and try it again. I wonder if this is holding it back. Should have an extra plot here. Okay. 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 Gonna take lunch pretty soon. This could be a way for me to just take lunch. I was hoping that we'd be done with this chapter before lunch. And then we'd have a good chance of finishing up the pivot tables by the end of the day. Yeah, okay. That's okay though. Let's see. It says that it's completed, but I don't see the plot. Plot's not there. Yeah. Yeah, the plot's not showing up. I think I'm just gonna go for lunch and then I'll be back in after I eat, and then we'll take a look at this here. So hopefully the plots will be ready by then. We still just need to create this one. Look at two categorical variables. Yeah, I have that here. Two categorical variables, categorical and numeric data, and visualizing multiple variables. So a little bit to get through. But shouldn't be too much more. How much did we do so far? Not much at all. Okay. Wow, we're just going really slowly. Okay. Yeah. So we'll be back. We will be back. Hmm. Okay. Still chomping on a sandwich here. But oops. We got our plot. And that was the code for it. Let me see if I can like zoom over. So weird. Okay. It's like locked. Okay. Lock it in there. So there's our code for making this kernel density estimation. So we do have a slight like difference here. Well, given that we took samples here, there's some details that are missing here. Or it could also just be the settings. With like the number grid size being 30. No, that's not it. Yeah, I don't know. There must be some setting within the KDE plot where you can get more of the levels there, the contour levels. Because this is what it looks like for the R. Oopsie, for R. The output from the R project here. Let me try to center this. There we go. There's some other little tiny features here that you can pick up. Like this was part of that other band that was above the main band. All right, so we're getting, so you can use this to, I guess, explore the shape of the data, what it looks like in 3 dimensions here. And let's see, where are we? Let me start a focus session here. Got 90 minutes on the clock. And I'm going to have to, like, every time I hear the bell, I'm going to have to drink some water. So I don't know why my camera's not coming back up. I'm going to hang on. We're back. There it is. There we are. Okay. Oopsie. Oopsie doopsie. My exercise ledger. My tracker's not working. The null nulls. Get rid of those null datas. Those are all the times that I mistakenly hit the button when I was not focused on Obsidian here. Alrighty then. There we go. Where am I going? I'm going to this book. We're going back to the book. Okay, so with that in place here. So this is the we get the nice looking plot like they got. Interesting that ours is only coming out in black and white, but that must be like some kind of like thing with knitter or something. I don't know why. I'm not going to dive into that. Okay. Okie dokie. So, oh, you know what? I kind of wanted to take a look at something real quick, just to like go back to what I was talking about at the beginning of this stream. My friend had sent me a, let's see, sent me a video of, this is a very short video of Elon Musk sending out a heart signal, sending his heart out. So, there we go. Let's bring that up. So that's it. That's what he's done in the past to show heart out. Puts hand like this, and then goes out. So why did he change it this time? Why is it different this time? I mean, even in this video, like he was like holding a microphone, and he was like trying to awkwardly hold the microphone and do that, right? I think. Let me go back to that. Ba, 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 ba. Yeah, he's got the microphone in his hand. He's got the microphone in his hands. And he's doing this like kind of awkward like half thing, and he does that. And then so when you're up there holding a microphone, you're able to do this and then spread it out. But you're at a daze, you're at a lectern, and you're like, I'm gonna have to put my hand to my chest and do a salute. And we're supposed to believe that that's his. We're supposed to believe that is him sending his heart out. We're supposed to believe that. You guys are on something. I gotta say, high on the cult, the cult ether, drinking the cult Kool-Aid, whatever you want to call it. So I am fired up today. I'm sorry, but this is maddening. It's maddening to me. You're just trying to restore sanity. Okay, let's finish this chapter. Let's finish the chapter here. I scared Hypatia with that rant. I'm going to take a quick little break to console her a little bit. So. Okay, she's good. She's good. Baby is good. She's actually right underneath me trying to get a piece of the sandwich. There you go, baby girl. There you go. Okay. So, my heart can't take this. Let's get back to this. So we were gonna read this sentence and try to understand the plot here, the contour plot here. So it's using contours overlaid onto a scatter plot to visualize the relationship between two numeric variables, those numeric variables being the finished square feet and the tax assessed value. And the contours are essentially a topographical map to two variables, right? Each contour band represents a specific density of points, increasing as one nears the peak. So on the peak here is like right here on that, right? That the density increases, basically, because you have like but the same number. Yes, represents a specific. So each contour represents a density of points, certain number of points there. Okay. So this plot shows a similar story as figure 1A, right? Where we plotted the hexagonal plot there. There's a secondary peak north of the main peak. This chart was also used using ggplot2 with the built-in geom density 2D function. Huh. I don't know why. Oh, we could change the color, couldn't we? Yeah, that's weird. I think it's just because I was black and white. That's why we're doing black and white. I'm not even paying attention to the code I'm writing here for R. Yeah, so you can specify the colors that you have there, the fill gradient. Yeah, okay, I should have noticed that. But anyway, this chart was also used with that, right? The built-in GM, and then we did the same thing with the KDE plot function from Seaborn. And yeah. Okay. Yeah, and that's our plot there. It looks pretty cool, honestly. Yeah. So other types of charts are used to show the relationship between two numeric variables, including heat maps. So heat maps, hexagonal binning, and contour plots all give a visual representation of a two-dimensional density. So let's yeah, so multivariate analysis, we can do contour plots, hexagonal binning, heat maps. So we should put heat maps because that's what we have there. Let's see. They give a visual representation of a two-dimensional density. There we go. Okay. So they're natural analogs to histograms and density plots, of course. All right, let's move along to two categorical variables. Those categorical variables. Do I have a... trying to think if I have notes for this. Okay, two categorical variables. We're on that part. Yeah. Okay. Categorical and numeric data. There we go. Okay, so we need to make this Python. And can I get this contingency table? Oh, we're going to be able to build that. So I think I'm going to just go ahead and try to build that, and then we'll read up on how to do that. So to build that, we have a loans pivot table. So we do need to define that. And so we need to get that data then. LC loans.csv. So we can use the, oh, what do you call it? Do the raw. Oopsie. Okay, so it's doing that. I just want the, let's see, go into here and do curl output, and we'll just get the name from that from there. That should work. And then we'll do read in the data from not quite there yet. So I think what I'll do is do Control Shift that. I thought it was Control Shift minus. There it is. Okay. We'll run that. Looks like it worked. It did work. Okay, so let's go over to our thing here. We'll get that back. And LC loans. Okay. Oh, wait a minute. LC. Wait, we need crosstab. We need to define the crosstab as the loans in the pivot table. So this isn't going to make much sense to me right now. Although it might. It might make some sense. I think I have a... I'm trying to remember what I know about pivot tables here. Definitely, it involves some aggregate function, right? And you're taking data in a two-dimensional thing and running an aggregate over one of the columns, I think. One of the columns or one of the rows. And then you're, yeah, constructing some, yeah, the two different like variables that go into it, and then you do counts or something like that from there. I don't know. I'm not very. We're gonna solidify that understanding today. So we're using the label location for getting the columns A through G. Or is that rows A through G, and then all columns of that? Yeah. That's the if.loc, luck, and then we do charge off to late from all columns from charged off to late, df.loc. Oh my god, what am I doing? Okay. df is equal to crosstab, and then we just make a copy of the result there. That's interesting. It's interesting. Okay, so we're gonna relabel or replace the data in those columns from charged off up to a late, and then div. I don't know what div does. What does div do? Floating point division. Okay. So you're taking each of those and then dividing by df all on the axis equals 0, I think, is columns. Or divide the rows with the row sum. Wow. Okay. Yeah, so this is going to take a while again, too, because I need to understand this. This is really something that's pretty important. And we're going to use that broadcasting to divide the every single value in the all column by the sum. By the sum. So we're like normalizing it. Okay, that makes sense to me. That you're going to normalize it there, so you get the percent or the what do you want to call it? The proportions. Okay. So we're trying to recreate this. So let's see if that works then. Percent crosstab is there, and then we can... I guess we can display it. Yeah, there it is. Okay, so that is recreating that. Late. Instead of... Wait, it doesn't have the totals. Yeah, there's something here. Item incompatible is deprecated. Cast to a compatible D type first, so we would need to just cast to a D type before then. Okay, so that's going to be. Oh, okay. So actually, maybe that is taken care of in the code here. So let's take a look at that. So we want to look at the loading of the pivot table crosstab. Oh no, it's just LC loans. CSV, there's nothing special there. Oh, well that's okay. Wait a minute. Can you just open up GZ files with that? With pandas? Let me try to find that. It looks for the KC tax CSV. Oh, I didn't know you could just load that in with the GZ. That's something to learn there. Okay, I don't even need to unzip it. I thought you would need to. Wow, pandas has come a long way. Okay. Let's go back to reality. There goes gravity. Nope. Okay, let's talk about this here. So I don't understand why there's two here, charged off, and then there's something underneath, and then current, and then there's something underneath that. Oh, it's the number. And then so it's the count, and then it's the percentage, I think, right? Something like that. Contingency table. So contingency table is a table of counts by category. And then we have a contingency table between the grade of a personal loan and the outcome of that loan. So this is taken from data provided by Lending Club, a leader in the peer-to-peer lending business. The grade goes from A high to G low. The outcome is either fully paid, current, charged off, which is the balance of the loan is not expected to be collected, or it's late. Okay. This table shows the count, overall count there, and then the row percentage. So if you add up each of these in the row, it should add up to 1. Okay, interesting. I don't know why you don't get that with pandas here. Okay, so I think I understand what we're doing here. So contingency tables can look only at counts, or they can also include column and total percentages. Interesting. Okay, so pivot tables in Excel are perhaps the most common tool used to create contingency tables. But in R, the cross table function in the desk package produces, okay. So I'll highlight that as well. So let's do that in here. Maybe it's a prettier contingency table, but I'm not holding that hope here. Everything's looking kind of janky on this this R Markdown notebook here. Let's see, library. Desker, which I'm going to assume that we don't have it installed. So actually, before I even do that, let's install packages. Desker. And xtab. Going to assign cross table to that. LC loans grade and LC loans status. Prop C? I don't know what that is. Property chi-square. False. Prop. I don't know what prop is. What is prop? Some kind of test. You're doing the tests on it for some reason. Okay, and then can I show like the table from there? Xtab. Okay, see if that works. We'll see if that works then. So we'll take a look at this code for pandas here. The margins keyword argument will add the column and row sums. Margins true. So we'll have the column and row sums. I don't see that though. Did I add that? Margins is true. And we're doing the aggregate function is going to be the length of x. And we're doing it over the columns of status. The index being the grade. All right, I'm not going to go too deep into this actually because we're going to go over this in depth in the real Python tutorial. Okay. Yeah. Hopper. Okay. So then we create a copy of the pivot table ignoring the column sums. So we just got rid of the column sums. So why did we do that? Okay. And then we added the DFL. We divide the rows with the row sum. Why don't we want the column sums? You get rid of the column sums and then you get rid of the... Yeah, but it ignored it ignored the row sums too. I must have done something wrong. Axis equals 0. Okay, so we're just ignoring the row sums? Maybe they weren't even there. No, because we should be having all of them, right? We should be having all of those rows. That's what that slice is there. And then we're ignoring the column sums by just choosing which columns. Divide with the sum, and then we divide all column by its sum. Okay, well that's weird. I heard the bell. It's time to drink some water. Okay. There's an error knitting the document. Let's see what the error was. Execution halted. Oh, of course, I didn't load in LC. LC loan. That was the name of it, right? Yeah. Okay. Let's knit that again. Make sure we save it. And then we're going to move on. Or I'm just going to move on for this one. And we're going to do categorical and numeric data. We're going to come back to the pivot tables, the two categorical variables, when we get to doing pivot tables in with that R Python tutorial. Should be linked in the description. That's what I'm going to do. Hopefully, at the end of the hour, we'll start that. You need to stretch out a little bit. My goodness, I get so tense. Ew. Muscles get tight. Mm-hmm. Okay. So box plots are a simple way to visually compare the distributions of a numeric variable grouped according to a categorical variable. So for example, we might want to compare how the percentage of flight delays varies across airlines. And then this shows the percentage of flights in a month that were delayed where the delay was within the carrier's control. Hmm. Oh, what happened? Still going? Okay. Oh. I wonder if I could set the eval for false for that other one. It's probably still taking a little bit of time for the one that's just above it. Oh gosh, that's annoying, honestly. But we are going to need. We are. I don't know why that's funny to me every single time. We need the airline data. We have DFW airline, but we don't have the other day. The other airline stuff. Oh, maybe it is. Maybe it is just that. Let's just take a look. Airline stats. Oh, airline stats. Oh, there it is. Okay. Okay. It's too large. Okay, but I don't want. Come on, please stop. Can we go back? Please. Please, please stop. Not asking for much here, guys. I'm just gonna click on download. I don't really want to deal with this. Getting the whatchamacallit. Come on, dude. Seriously, what is wrong with you? Okay. Let's try to curl it from what we knew before. Can I find where? Yeah, let's take it from there. Let's take it from here. All right. Okay. Try to get that data. What is going on? Come on, dude. Seriously? What is happening? Why can't I convert it to Python? So dumb. So dumb. So we'll look for the airline stats. Okay, seems to have worked. Ay, 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 ay. Go back to here. So we'll do the other thing, but we'll do the box plot. So we did get the data, so we'll have to read in the data as airline stats. We're gonna read CSV. Okay. And then it's just as simple as just doing a box plot, percentage carrier delay. And then it's against airline, right? So percent carrier delay is going to be X, and then, wait, no, on the Y. So it's Y versus X, right? Is the Y tilde X, Y versus X is the way that I usually think about that. Or you can, in other words, you could go dependent variable versus the independent variable. That's 50. I don't know what that is. It's just the ends, the end points there. Did we finish? No. All arguments must have the same length. Error in table. Okay, I don't understand. Can I like show what xtab is? Can I print it? I don't even know. All right, so eventually that will end up showing. And we're getting to a point where it's just taking a long time for all those things. I could probably have broken these things up into separate little bits, but that's okay. Maybe I'll think about that for the next chapter. Let's try to make a box plot in this sense with the what are we doing here? Like categorical data by airline. Okay. And column is the percentage carrier delay. Okay. Set X label blank. Set Y label. The daily percentage of delayed flights. Can I escape that? No. I think I do need to do it. I don't have to escape it, I guess. Just looks funky then. And we put a subtitle, super title of nothing, apparently. So let's see if that works. Airline stats is not defined. Well, uh, okay. Percent carrier delay. So we get the same looking type of plot that they got here. And then, so what's the difference here is that we're doing facets here, right? We're broken down by airline. So for each airline type. We're plotting the data there. So okay. Well, that's still the same as doing, right? So distributions of individual, like, yeah, of um, conditional based on which airline. Okay. Uh, take your word for it. Let's see if this is gonna work then. I just say print. Maybe I shouldn't even do that. I don't know what I'm doing here. Hmm. Ah, that's weird. Okay. All right. Yeah, I'm a little lost here. So it says Alaska stands out as having the fewest delays, right? Yeah. Alaska Airlines stands out as having the fewest delays, while American had the most. What? What does that mean, though? I mean, yeah, there are some days that are uncharacteristic, right? That there's a lot more delays. Oh, okay, yeah, because we're looking at the mean. Okay, so we're looking at the green bar in the middle of the box plot, or the median, I should say. We're not looking. That doesn't plot the mean, right? That's the median. Uh, I think I'm pretty sure. Okay. The lower quartile for American is higher than the upper quartile for Alaska. So, yeah. Just in general, you're going to be delayed more than Alaska. Yeah, most of the time. So, a violin plot is an enhancement to the box plot. Plots the density estimate with the density on the y-axis, so going vertically rather than seeing it horizontal like we've been kind of used to. The density is mirrored and flipped over, and the resulting shape is filled in, creating an image resembling a violin, or sure, if that's what you want to call it. Uh, the advantage of a violin plot is that it can show nuances in the distribution that aren't perceptible in a box plot. Yeah, yeah. Yeah, so like you can see like if there's more, you can kind of see the skewedness more than you can in a box plot. Like you might be able to see some skewness in a box plot. Like the United one kind of looks like it might be a little bit skewed, but it should be more pronounced in a violin plot. So on the other hand, the box plot can more clearly shows the outliers of the data. And so in ggplot2, the function geom of violin can be used to create that plot. So I think we might have to even install that though. ggplot data is going to be airline stats. The AES is the airline with the percentage carrier delay there. And so you create that object, then you add onto that object limits, your y limits, and then we're going to use this violin function Labs is gonna, I don't know why that's all messed up. Your labels are gonna have a blank label for X. Y is gonna be the daily percentage. Okay. All right, so we should have, yep. Oh, okay, so we are able to print the crosstab then of that. Yeah, I guess that works then. Here's some difference with the table. So I wonder if I can run this chunk. Could not find the function ggplot. So we don't have everything like installed there. Can we like run above? Oh, right. Okay, never mind. All right, so we'll just knit it. I got to figure out how to do that. Yeah. Oh boy, I'm tired. Boy, I might need a nap. So while that is knitting for the 100th time here, let's go ahead. Create a violin plot using Seaborn. We'll use an airline stats. Don't like that syntax there. We're going to use the brackets. We're going to use an inner of the quartile. I wonder what inners mean there. What does inner mean? Let's see. Yeah, I don't know. Inner quarks. Huh. I do like shit. Violin plot. So inner doesn't tell me what that is. Box. Yeah, there's just a lot of stuff. So it could be instructive to go through each of them in depth, but I'm not going to do that unless I have to once I start building a project, I think I'm going to think about the plots that I want to make, and then the plots in building the plots, that's when I'm going to dive in deeply with all of the parameters that the violin plot thing makes, or whatever plot I'm going to examine there. X label there. Set our Y label as daily percentage of delay line. Hopefully it doesn't take too long, and there's an error here because of airplane. Oh. Airline, not airplane. Okay, and then there's something wrong with this here. It's yeah, okay, so I think I know what's happening. So same thing. There's a different syntax now. We're doing airline stats, and then, or actually, let me just do this. There we go. And then the X can be airline. Or in this case, I think it's by. Let's try by. No? Let's see what come on. Violin plot the X and the Y, so you take two different column names. The vector. Okay. We're sure that's what we're going with? Okay, so it takes X and the Y for the violin plot, which is gonna be weird because what does X mean? And what does Y mean in that context? Like it makes more sense in the R, in the way R does that. With that, look at that, they look like little dreidels or something. Little tops. You can spin them around. So yeah, see a lot of delta. I guess, are those outliers, like all those ones that are on there? I guess they're included in there. So like long tails. And then comparatively to R here in the bottom. R, okay. Yeah. Should I shrink this down? You know what? Maybe that is better. Because then I can zoom in. Let's shrink it down even more. Let's go to 75%. And then I can fit the whole plot in on my zoom when I zoom in. Isn't that handy? Yeah, lock that in place. There we go. Yeah, so we have the distributions. You look at that. It kind of just looks funky, right? Because I guess like because you're plotting them uh because you're mirroring the density estimation, um it really becomes apparent where the like the thickest parts are and the thinnest parts, which is going to be the yeah. So it kind of exaggerates those features so that you're able to visualize where the bulk of the data is. Yeah. Okay. These could also be like green onion uh, plots, right? Let's go on up to this plot here. Let me see if we can get that centered here. There we go. So yeah, they're in a different order here. American. They're okay. So I don't know what the order is. It's not alphabetical. Uh, R sorted the column names as alphabetical. This is not sorted alphabetically. Um, so, well, with these, they actually show you the interquartile range, don't they? Looks like it. Looks like they are. Looks like they're showing the interquartile range, the IQR, right? Interestingly enough. Okay, so I think that's good. Alrighty. Violin plot shows a concentration in the distribution near zero for Alaska, right? Near zero for Alaska. That's very far down there. And then to a lesser extent, delta, right? Delta here being slightly above, right? This phenomena is not as obvious in the box plot. You can combine a violin plot with a box plot by adding geom box plot to the plot, although this works best when colors are used, right? So you can add that to the ggplot code. So if you add the geom box plot to that code, it will yeah, I don't know how to do that. I got to learn how to do the grammar of graphics stuff. Sure. But yeah, this one kind of looks like the Python one there. So I don't know what that means. Just that I think that they were using. I don't know how they were what their parameters were for setting all these different plot things. Why they're not like standard. Why they're not coming out looking exactly the same. They look different than both the Python and the R plots. So, okay. All right, we're going to visualize multiples, and then that's going to do it for the chapter. And then we're going to take a break, and then we're going to come back, and we're going to do pivot tables. So let's get this one done. Let's go with visualizing. Multiple variables. Save that one. Okay. Right, facets. So facets were kind of used in the previous plot, right? But they're going to be used more on this one. Facets are different plots in they're like subplots in R. Okay, so the types of charts used to compare two variables, scatter plots, hexagonal binning, and box plots, are readily extended to more variables through the notion of conditioning. As an example, we'll look at the figure 1.8, which showed the relationship between homes and finished square feet. That was this one, right? We observe that there appears to be a cluster of homes that have higher tax assessed value per square foot, right? A class in, was it this one? Diving deeper, we're going to use the same one, and then we're going to account for the effective location by plotting the data for a set of zip codes. And then the picture is much clearer. Tax assessed value is much higher in some zip codes than others. This disparity gives rise to the clusters. Okay, so we're going to take a look at faceting. Oh, right. So faceting, basically conditioning. Yeah. Conditional variables, right? Yeah. You're going to plot some output given the data, conditioned on it being one piece of the data, right? One subset of the data. And then you're going to take all those different subsets, you're just going to partition it, and each partition is a facet, right? Okay. ggplot. I should probably do the ggplot one and then like wait an hour for it to finish because we're at the end of the notebook. So we wanna. This is only really scratching the surface with this, though. I think visualizing multiple variables and stuff can go even deeper with a lot of other ideas. Subset KC tax. So we already have that. Loaded in, and we have zip code in. Interesting. Yeah. X is equal to square foot the living, and Y is equal to the tax assessed value. And you create that ggplot object, and then you add on some bin hexagonal binnings. Hexagonal bins. Change the theme to black and white. I guess that's where it's coming from. The black and white theme. And then the scale fill gradient. On the low is white. On the high is blue. Oh, we're going to change it up today. Okay. We're going to get some color in these plots now. Finished square feet. with our labels, X and Y, text to sets value. I already did this before, so it's like not annoying. Keep typing the same thing. And then you add on the facet wrap zip code. Okay. And we'll see how that works. See if that works. And then we'll try to do a similar plot. Constructing our own hexagonal bin here. So we're going to get our list of zip codes. And we're going to take 98118. I should just copy it from the other one. 98105. 98108. Ooh, time for some water. Gotta get some water. Okay. Yeah. I forgot to drink water yesterday completely. So much so that my mouth was so dry that I got a chapped lip on the bottom of my lip, and it was cracked. It was cracking. Believe that? Never thought that I would experience cracked, chapped lips when I moved to Arizona. Okay, so they're using zip code and doing a is in the list of zip codes. Interesting. I haven't used that function really before. That's interesting because I always did it differently. Oh wow, that's so funky. This is so much easier though. It's so much prettier for one, the code. I would always use a map apply, and that would be probably not good. It probably would take a long time. Versus that looks like it's probably an optimized method. So let's go ahead and create this one. KC tax zip code, and we have yeah, so we've pared down the data set. So we can actually see that we have 100. Oh, we only have 19,690 as opposed to 426,000. So improvement, right? We will create a function, apparently. Going to take X, Y, color as positional arguments, and then we're going to take keyword arguments, pass some keyword args into that. Which I'm betting is going to be used for Seaborn and the underlying matplotlib library. Just allow you to pass through variables to adjust the plot. You know, SNS light palette. Interesting. So, okay, what does that do? What was that? It makes a sequential palette that blends from light to color. Color parameter can be specified in a number of ways, including all options for defining a color in Matplotlib and several additional color spaces that are handled by Seaborn. You can also use the database of named colors from the XKCD color survey. Interesting. I'm gonna have to actually look that up. Let's look at that up. KCD color survey. Oh, come on, give me full screen. This is all the way back in 2010. Color names if you're a girl. Okay. Oh, that's funny. Okay, I got to I'm guessing it's this one. Or maybe not. Oh, it is. It could be this one. Let's add that to our list of resources that we went through today. And we'll take the color survey results and look at that because that's pretty funny. Okay, so funny. So it's like people naming it right. If you ask people to name colors long enough, they go totally crazy. Puke and vomit are totally real colors. Yeah, I used that before. Puke green, putrid yellow. Colorblind people are more likely than non-colorblind people to type fuck this or something and quit in frustration. Indigo was totally just added to the rainbow so it would have 7 colors and make that Roy G. Biv. Let's increase the size of this. Would have 7 colors make that Roy G. Biv acronym work just so like you always suspected it should really be Roy GBP with maybe a C or T thrown in there between G and B, depending on how the spectrum was converted to RGB. A couple dozen people embedded SQL drop table statements in the color names. Nice try, kids. Nobody can spell fuchsia. Where does fuchsia come from? Is it like fox or something from German? Overall, the results were really cool and a lot of fun to analyze. There are some basic limitations in this survey, which are discussed toward the bottom of the post, but the sheer amount of data here is cool. By sheer strange coincidence, the same night I first made the color survey public, the webcomic Doghouse Diaries put up this comic, which I altered slightly to fit in this block. Click for the original. Color names if you're a girl, color names if you're a guy. Yeah, definitely. Definitely. Like those are both reds, purples, just shades of purples, pinks, orange. Probably because like women uh go through especially women who are like aware of cosmetics, cosmetics aware women who, you know, learn all of those different colors from experimenting with different makeups. It was funny, but I realized I could test whether it was accurate. I don't know. That's just my theory. I don't know. Like, do you learn that like earlier in life before makeup? That'd be good. Something interesting to look into. Using the most frequent color name for the handful of colors in the survey closest to the ones in the comic. Actual color names if you're a girl, actual color names if you're a guy. Okay. Oh, so use the yeah. These are all green. They're all the same color. I guess they're just slightly different as far as like the RGB codes or the hex codes are concerned. So women were slightly more liberal with the modifiers, but otherwise they generally agreed. And some of the differences may be sampling noise. The results were similar across the survey. Men and women tended on average to call colors the same names. Okay, so I was feeling pretty good about quality, and then I decided to calculate the most masculine, oh gosh, no. Looking for the color names most disproportionately popular among men. It's got to be like gunmetal or something for men. Black, steel. The names that the most women came up with compared to the fewest men. Here are the color names most disproportionately popular among women. Dusty teal, blush pink. Dusty lavender, butter yellow. Dusky rose. What's the difference between dusty and dusky? Is dusty like speckled or like taken down in the grayscale or like something like that? And dusky rose, maybe putting some orange into it. I'm not sure. Pretty flowery, certainly, kind of an incense bomb set off in the Bed Bath and Beyond vibe. Well, let's take a look at the other list. Here are the color names most disproportionately popular among men. Beige spelled wrong. I know it's that's not my type of number. The only actual color in the list really is a misspelling of beige. Keep in mind, this is based on the number of unique people who answered the color, not the number of times they typed it. This isn't just the effect of a couple of spammers. In fact, this is after the spam filter. I weep for my gender, but on to RGB values. Okay. Full table there, also available as a text file. I have no opinion about whether it should be used to build a new X11 RG. I don't know what that is. What's that referring to? Yeah, okay. Cool. The different fuchsias. No one can spell fuchsia. You may notice that the correct spelling is missing. This is because I can't spell it either. And when running the analysis, use Google's suggestion feature as a spell checker. A friend pointed out that to spell it right, you can think of fuchsia. Okay. Misspellings aside, a lot of people spammed the database, but there were some decent filters in place. Interesting. Oh, wow. What is this? Oh, wow. Interesting. So cool. With all the regimes here. So, like most three fully saturated faces of the RGB cube colors where one of the RGB values is 0. Uh-huh. Huh. That's so interesting. Huh. Oh, wow. Okay. Okay, so that's why it's 3, is because so in this region, it's the red and green. Red and so fully red, and it's kind of like blended over to this side. You could like create a cone out of it. So fully red with no green and no blue, going on over to all green with no blue and no red, going on over to all blue with no green and no red. And then the in-betweens are, yeah, are what's interesting there. And then you can get, I guess, yeah, so crossing over from probably this line, I guess. Yeah. Oh, that's weird. Oh boy, I need to take a break. We're gonna have to just make some comments on the other thing. Okay, so this is like some list of colors here. Interesting. What is this? This is just the X window system. Windowing system for bitmap displays coming on Unix. Like, okay. And is this a standard or something? Or W3C specification? So that is the Web3 consortium, right? The World Wide Web consortium. Yeah, okay. I don't know what I'm looking at. Okay. Um, okay, so we're gonna finish this one. Here we go. Okay. What was I reading though? Where did I get that from? In the ones from the color survey. Where did I get that from? Oh, that's right. It was from the light palette. Wow, I'm just trying to like backtrack like where my brain got derailed. C map, color map, C map. Pass them quarks. Pass me some quarks. And then, okay, so let's define that. And then we'll create a plot with a facet grid of the KC tax zip with the zip codes. And the column we're going to use the zip code. And the call wrap, what does that mean? Using arguments call and row to specify the conditioning variables. Right. For a single conditioning variable, use call together with call wrap to wrap the faceted graphs into multiple rows. So we're going to wrap it into 2 rows. Is that what we're doing? Then we take that object and we create a map passing hexbin into it, the function. So we pass the function into that square foot total living tax. This might get throw an error. I think it's going to probably throw an error. Like the assessed value, and then the extent is 3,500, 700,000. Okay, that seems to work. Then we have axis labels, finish square feet, and tax assessed value. And then we set the titles of each of the facets, right? So zip code being the column name. Well, that's weird. Why is it like that? You don't send it through like that. You send it with a formatting, right? Send it with that format string, the column name. I'm assuming this is gonna fail. Yeah, but where is it gonna fail? It's gonna fail at hexbin. Where I thought it was going to be, not enough values to unpack expected 4 got. Oh, well, it looks like the zip code thing was actually working. Weird. Totally weird. Okay. Not enough values to unpack with the quarks. Facet plot, hexbin. Three. So you have function and axis, and you have the plot arc. So the axis. Right. Okay. I think it's in there. Huh. Maybe, maybe not. We should, we should just like color number of colors defaulted to 6. Reverse defaulted to true. So the color type. Where's the CMAP coming from though? CMAP equals true. Then plotting the hex bin. X, Y, C, grid size. Yeah, so the only ones that you need are that. See if it came up on here. All right, so it came up on the for R. This is what we're looking for, but I'm getting some errors with yeah, with the other one, with the pandas or the Python. Let's check the code on GitHub and see if we're missing something that's been updated. Okay. So that looks good, actually. The hex bin XY color Quarg's CMAP is taking in. Light palette is taking in color as CMAP true. And then PLT hex bin in. What the heck is that? Okay, well that's the problem. PLT hex bin. Let's see if that works. No, there's going to be an error there again. But there's still an error there. It's coming before. Okay. SNS facet grid. Tax assessed value. Looks good. Square total feet. Total living. Square feet total living. Oh, wait a minute. Did we miss? It was that. The X, Y, and the min. Okay, that was the thing. It was looking for 4. Right. Okay, so we missed the 0. That's what we missed. See if that works. There we go. Now we got it. Now we got it. Okay, let's break that down. All right, we got a facet grid here, and then it says zip code that. So let's oh wait, can't we like open this up in another thing? There it is. Can I move this out? There we go. Let's move it out. Oh, come on. No. No, no, please. Go back. Go back, sir. Where did you go? Where did you go? Let's. There we go. And then it's disappeared for some reason. So let's go like that. Okay, maybe it's not working. All right. Well, we could save it. We can save it. Copy to clipboard. What does it mean to copy it to clipboard? Can I like? Oh, there it is. Maybe I should have been doing that, you know? There it is. That thing. That's the thing. That one right there. That guy. That's the one. Faucets, faucets, faucets. Okay, so let's see what we're doing. Let's go back to over here. So we're going to look at the code a little bit. So we're looking at this little bit here and what this function is. So the map method calls the hexbin function with the subsets of the original data set for the different zip codes, right? Extent defines the limits of the x and y axes. That's what I presumed was happening there. I just didn't vocalize that. Huh. Concept of conditioning variables in a graphics system was pioneered with Trellis graphics developed by Rick Becker, Bill Cleveland, and others at Bell Labs. This idea has propagated to modern graphics systems such as the Lattice and ggplot2 packages in R and Seaborn, and Bocal modules in Python. Conditioning variables are also integral to business intelligence platforms such as Tableau and Spotfire. With the advent of vast computing power, modern visualization platforms have moved well beyond the humble beginnings of exploratory data analysis. However, key concepts and tools developed a half century ago still form a foundation for these systems. Okay, we'll highlight that. Okay, further reading modern data science with R. Heard of that book? ggplot2, The Elegant Graphics for Data Analysis by Hadley Wickham, and the man who he created the whole thing. So, it's got to be pretty good. Joseph Fruwald has a web-based tutorial on ggplot. Just like if you're in OBS Studio and you use any of the plugins, like Exceldro creates a whole bunch of these plugins, and then you can watch his YouTube or any kind of explainers. Usually pretty good. Pioneered by John Tukey. So the summary is that EDA is pioneered by John Tukey, set a foundation for the field of data science. The key idea of exploratory data analysis is that the first and most important step in any project based on data is to look at the data. So let's just highlight that. That is the most important thing. By summarizing and visualizing the data, you can gain valuable intuition and understanding of the project. This chapter has reviewed concepts ranging from simple metrics such as estimates of location of variability to rich visual displays that explore the relationships between multiple variables. The diverse set of tools and techniques being developed by the open source community, combined with the expressiveness of the R and Python languages, has created a plethora of ways to explore and analyze data. Exploratory analysis should be a cornerstone of any data science project. There you go. Let's go back to this sentence on. So it was explaining the plot here. I seem to have lost the plot. Right. Okay. Man, it is. It is 3:15, so we are running up against the end of this day here. So hopefully we can get through some of the pivot table stuff. But I don't know. Let's see. Okay. Right. I wanted this chunk over here, and then I moved this over. I messed it up. Okay. So move down, right? Okay. Hmm. Oh, that's how you get that up. All right. Okay, so we observed that there appears to be clusters of homes that have higher tax assessed value per square. So we dove deeper and we looked at specific facets of this by plotting the data for a set of zip codes. Now the picture is much clearer. Tax assessed value is much higher in some zip codes, right? Some zip codes, it's higher than in others, right? So this one down here, 98188, much lower than where it is in 98105. Yeah, so that's the interesting how you can see different things going on from there. Okay, something to take into mind when we're exploring data like this. Okay, um, that's the first chapter of practical statistics for data scientists. Let's go to the cover there. And gonna work on the second chapter of this in the coming weeks, probably starting next week. Um, so yeah, um, it's Wednesday already. Wow. Okay. So I'm gonna take a break with this. And when I come back, we're gonna do the real Python. So I can get rid of this and just get set up here. Yeah. Okay. It is time for a break. Okay. So I'll just close that then. So we're done with that. We're done with this stuff for now. In fact, I think what I want to do is, like, since this is probably pretty useful, is to take all these and let's just add them to a tab group, move tabs to a new group. And this is going to be um, PSD. Yeah. PSFDA. Um, yeah, call it that. And yeah, and then we'll save the group. And then so they're automatically saved. Which is kind of what everybody wanted, right? I don't understand why they had that as an option. Like, I don't know. It was optional for a little bit there, for a minute. So, I think what I'm going to do let's bring up the real Python for pivot. How to create pivot tables. I'm going to go and, oh, okay. So we're not even on this thing. When I come back, I'm going to do how to create pivot tables with pandas. So learning how to do these things. All important things to know before I dive into the projects here. Yeah. So I'll add this to my Obsidian, and we will move it to job notes. And actually, I forget where I was keeping it. No, I think we will move it to job notes. I just don't know where I had the other thing. There's an interactive quiz, and I don't want to take the quiz today. I want to do it like some other day. So I'll get somewhat set up for that. Okay. When I come back, we're going to do this. All right, I got to take care of a little thing here. We got to figure out which one of these fuckers. Did this here. Well, they already voted, right? Oh yeah, because we already know that fucking goddamn Ruben Gallego, goddamn asshole. Yeah. Mark Kelly, Ruben Gallego. Yeah, they suck. They suck. Let's just make a list. Check it twice. Shaheen. Jeannie Sheen. Garbage. Oops. Thought we were doing that. Let's see if we could do this in LibreOffice. Calc. Don't want to use Google Sheets. Not gonna use Google Sheets no more. Not recovered. I don't want to recover that. Just discard it. Yes. Wait. What do I want to do? I don't know what the hell that was. Oh boy. Yes. All right, let's see if I can do this. Working with data, survey representatives. Can we sort by state? Is there a way to sort by state? Sort by state. All states? I'm assuming Stanton. What district is this fucker in? Fourth. Wait a minute. Which district is that? Yeah. All right. Tempe and Mesa, and then Chandler. Man, maybe I do. Maybe I do like political stuff. Maybe I do that. Maybe I do political data. So there's a tip here, but it's broken. So it's that. So what are we doing here? We need to import data. I need to import stuff. Can we like copy and paste? Can I just like paste in the data? If I paste it like special, paste special, unformatted text, stripped hypertext market, unformatted text, use text import dialog. That's what we want, right? The Unicode standard. Why is there? It's not separated by tab. Space. Fixed width, is that what it was? What is it separated by? Why is there only two? What happened to the other columns? Where are the other columns? From row one, okay. Oh, wait a minute. Oh, that's a weird way to do that. Oh, but you know what? You know it. Ooh. Maybe we could figure out how to do it with Python, right? I don't know. Because this has to be a table from there. Maybe we could figure out how to do this. Yeah, table head is there. Table's there. Yeah. All right. Let me try something because I think what we're going to do is we do the data analysis. We were reading it in from HTML is what we were doing. So Python for data analysis. And what we were doing was looking at the data read in HTML, right? We were reading in HTML, and this is what we were doing. I'm just going to copy this And what I'm going to do is to do a new one. So let's create a new notebook. Okay. Yeah, I'll just do it right here. So what I want to do is to do a yeah, so house votes Lincoln Riley, and we'll do the iPie notebook. What am I doing? uh, code. Code there, and then we create yeah, we could have just done touch as well. We're going to have to set the kernel to that, and then all votes to all parties. See if that works. See if we can get that. See if we can get that data. So we're going to paste that in. We're going to get a kernel from there. And PD, so we need to import pandas. So let's go. That's that. And hey, please, please. Okay, so the data frame. We're going to look for, what we call it? We call it bond novel title. So votes table. And then we'll just get it from here. I don't know though, because like I don't know if we can actually get it. It should strip out the table that's there, but I don't know if it will. Let's see. Let's just see if that works for one. And then we'll take a look at the votes table. Oh my goodness, it worked. Look at that shite. Oh, that's cool. Okay. Cool. Cool. Okay. But what we need to do this is a list, right? So we need to take okay, so if I look at the first thing, that gives me oh my gosh, look at that. It's the table. Okay. Okay. What is this thing? What is this type? It's a data frame. You're get the F out of here. Get out of here. Get out of here. Okay. That's a data frame. So now we can go votes aggregated df as that. And then we can just like we can take a look at the it's cool. Cool. Okay. All right, and then what we can do from the votes table, we can do okay, so from here, from the votes. Votes table. So, oh wait, what was that one? What was it? And then it was convert D types, right? Okay, so if we want to get the votes df, we can get the votes table, and we can take the first one from there. So first off, let me just take a look at that, and that should be a data frame. It is. There's just there's nans. We can remove the nans, I think. Yeah. I can do .loc with the. Actually, I don't know. .loc where there's no named index. That's the problem. The label. Yeah, we can do it with the. Okay. Unnamed 4 and unnamed 5. Yeah, so what we want to do is to convert key types. And then I can do votes df is equal to that. And then we can do drop NA. And then I can take a look at the votes. Yeah. Yeah, there we go. And then you have 433, the tail there. Okay, cool. Okay. Now we also just we need to like rename a column. So I really need to just yeah. Rename columns or index labels. Right. And then so what was the mapper is going to be what, a dictionary? Yeah. Rename columns. Rename columns. Unnamed 4. Actually, you know what? Let me take a look at something here. Unnamed 5. Okay, yeah, that is it. So it's unnamed. 4 is going to be state abrev. And unnamed 5 is vote. Oh, you know what? I think the yeah, we need to just rename all of these. And then I need to drop party. Yeah, I need to rename all of these. That's the problem. Vote nay, so yay, nay, so yeah, for some reason it came up with an extra column. So we'll do representative, we'll do party, we'll rename party to be drop drop me. Drop me. And then we'll do state gets mapped to party. And then vote gets named to state. And unnamed goes to state of burr, and then that other one. I think that works. So we have drop me, we have representative, drop me, party, state, abra, and then a vote. And that's object. So we're 33, we have state, state, abra, and then we have vote, we have drop me. And then so what we'll do is we'll just do votes df. Okay, so we do need to like dropping And then we'll do drop. There we go. And then if I look at this again, quotes, yes, we get that. Yeah, cool. Okay. Now, I'll be right back. I got it. Hit the bio. Do a bio break here. Close this down. Okay. That's what it is. Okay. All right, so we're going to take this. Let's not use LibreOffice. What I'm going to do is I'm going to take the Votes DF from here. Get rid of that side thing there. Yeah. All right, so these are that. What I want to do is to create a new thing. So I want them yay votes and them yay votes. Okay, and what we're gonna do with that them yay votes is gonna be and what I want to do, I want to take the name, the representative name. So, well, actually, what I want is my new series, right? My output series basically is what I want. I want the dem yay votes from the representative, and I want to concatenate that with, well, for one, I want to have that, and then I want to have a space, and then I have, I think this is how I can do this. Dem yay votes of state aber, and then we'll do this, and that should be some state output series. So output series should end up being like that. There we go. And so I should strip away the, yeah, so what we need to do is to remove it from here. So what I'll do is I'll do something like this. Dem yeah votes plus yeah, I guess like that. And yeah, that'll work. Okay, so we want to fix this. We want to do a replace, and then we want to use a regex thing, right? Regex true. So we'll replace, we have to match a pattern. I forget how to do this. We're going to say regex equals true. And we're going to replace that with nothing, right? Yeah, so what we want is they're going to have a space, and then they're going to have that, and then they're going to have um, something in between there. I think that might actually work, and I think you have to put like an R there, I think. I think that works. Gonzalez, comma. So we also just want to strip that as well. Um, and so what we'll do is this is kind of getting a little hairy, but it should work. It should work. I might be violating some style guides here. Strip, or isn't strip a thing? Or it's not string split, string strip? I guess we could just replace comma with nothing. What is it called? What is that function called? I thought it was just strip. Or like R strip? Is that what it is? No. How do I do that? String strip, but that's not on there. Oh. Oh, it is there. We'll just say an R strip on that. There we go. That cleans it up. Um, so we can do PD. Um, do CSV. Can we do two text? To Excel, to list. Interesting. To Markdown. Ah, that's fun. Let's try to Markdown. That's interesting. Let's just do that. Um, I guess that doesn't do it. Why do you need tabulate? I don't know. I guess that's not a thing. I guess I could just do it as that. I guess we just do to list and then to text maybe. Mm-hmm. There we go. Oh, shoot. Open it up in the text editor. Try again. Why? That's weird. There we go. Scrollable element. And I can take all that. And I can just put it here. Okay, so hopefully. I wonder if I could work on like reporting. That would be fun. Madness. What's happening at the professional space? Okay. Well, that was fun. That was a fun little aside there. Got to utilize my, the things I learned here. And I got to put some knowledge to use here. And so what I did here with this thing, let's just go through it. Let's put a gathering. So creating all this sense ominous. uh, but let's just say which Democratic. Import pandas. We're going to obviously, I mean, that speaks for itself. Here we are. Six columns, right? Six column names. So get subset of the data, and then we're gonna to put that in like another quote thing there. Would be good. And then I'll put to list, yeah. And then so this is just obvious. That's just obvious. Just print the list. That's all we did, and that's it. And so something I can come back to here. House votes Lincoln Riley, and we have Lincoln Riley Democratic. Yeah votes. I mean that's list. I kind of don't like it as that. Delete it as that. Okay. I don't know why it's under that. I'm gonna move it up here. It doesn't need to be in those things there. So that's it. That's a little notebook on taking data from a table on an HTML and creating a list from that. So there we go. That's what we did. Okay, so this is, yeah, some interesting data here. Use it for good. Okay. Okay. All right. It is 4:30 p.m., isn't it? Oh, I should have organized it by what you call it, shouldn't I? That would have been better if I had sorted this. Um, Here, what it was is sort values, right? And then there it is. Okay, that's the better way of doing that. Okay, I think, yeah. Okay. Okay. Right, you're back. Did you go? Did you go? You need to go outside? Okay, so that's that. Let's go ahead and make a directory of yeah, so we're in analysis projects. I don't know why it, yeah, it's so weird. Huh. So we'll say real Python, and we'll call this how to create pivot tables. um, I guess we'll just say pivot tables pandas. I mean, there's only really one way to do it. Um, 58. So we will do a new hmm, uh, create a new notebook here. Just call it pivot tables. iPy notebook. Save the sucker right there. There we go. Okay. Pretty cool. Okay. Select the kernel. Coinal. Okay, so what are we gonna have? So I got to take a look at what we have here. So you know what? Oh gosh, are these? They are. That's nice. Okay, so I can reference all those. So I'm gonna go back to my. All right, so we were like reading this. I can go over all these. I should review these at the end of the week or something. Um, yeah, I should. All my highlights I should review. Yeah, always good to refresh the memory. So let's go over to today, day 10, and it's going to be. Oh my God, what am I doing? That one. There we go. And so what we did this. So we did yeah, that one. And then we did doing um pivot tables of pandas, real Python. What other real Python ones do I have? Python for data analysis, real Python. Okay. And we'll just do the, and I'll put in the table of contents in here. How to create, so it's going to be pivot tables with pandas. So we'll start with the overview here of what we're going to do. I wish I could just do all of these. Using group by intent, that's got to be an error there. Yeah. I'll have to go in and edit that. Subcolumns, pivot tables, sub rows. Multiple values. Performing more advanced calculations. And then I gotta where is it? Like, okay, let's look up for aggregation. There we go. Using There we go. And then let's look up conclusion. That's at the bottom. Okay. So that is in there. Yeah. So um I'm putting all these in here knowing like full well that I'm probably not going to finish all these. So the reason being is that I'm going to I'm just going to copy them over into the next day, basically. And do that there. I'll do these meetings. Let's just say that the EPA webinar was canceled. Okay, so how to create pivot tables. I don't know. These things just irk me for some reason. There we go. There's a quiz at the bottom there. Yeah, that's fine. So there's crosstabs we're going to talk about, all these other things. It's very important stuff, right? Crosstabs are very important to understand. So what are we going to do? We'll call this how to create tables with pandas. We'll just take the, oops, where am I? Oh, oopsie. Yeah, let's do that. So a pivot table is a data analysis tool that allows you to take columns of raw data from a pandas data frame, summarize them, and then analyze the summary data to reveal its insights, right? Pivot tables allow you to perform common aggregate statistical calculations such as sums, counts, averages, and so on. Often the information a pivot table produces reveals trends and other observations your original raw data hides. Okay. Pivot tables are usually done oftentimes to aggregate some data so that you can investigate differences between two categorical things. So you like aggregate counts. If you want to investigate some relationships between two different categorical variables, you can like see that with a crosstab, and then you can also do like a chi-square test to see if it's a significant difference between two different groups. Right? Sure, we'll probably going to talk about that in here. That'll probably come up in the statistics for data scientist book. And righty. Okay. So I think I'm gonna. Okay. All right. I gotta be right back. Anybody else sick of that hold music, or that waiting music? It's been 2 days and I'm already sick of it. I gotta diversify the playlist here. I gotta add some more songs to that. But I've been kind of stingy, like trying to curate them, going on Pixabay and like trying to find ones that don't have the content ID. To screw up my whatever you want to call it. Ooh. Oh, something happened here. I dropped my headphones, but I don't know where the other one is. Where'd it go? Oh no. Uh-oh. No. Oh gosh. That's why I need to derail my head here right now. Let's see. Okay, she's gonna go to drifting. Okay. Um, okay. Okay. Yeah. It's gonna irk me now. I'm missing one of my headphones from my case here. Where did it go? It dropped somewhere around here. It's here. It has to be here. Oh. No. Where'd it go? Oh, it's just gonna. Hmm. It's gonna sauce my tenders here. No, where did it go? Probably stole it. Oh no. Oh gosh. I guess I'll try to look for it after I'm done with this, but that's disappointing. How would that have happened? How would it have happened? So this would have fallen down, would have opened up, it would have fallen out. Gotta do some CSI here. Where would it have fallen? It would have fallen behind there. It might have fallen and dropped, or fallen and dropped top of there. It's not on top of there. Oh man. Crime scene investigating with Kevin here today. I hope Opal didn't get it. That would not be fun. I doubt it would have fallen under there. Could have. It's like with this. There it is. Aha! Sanity restored. There we go. Let's hope that doesn't fall back down again. Okay. Yeah. Ooh. Wow. Okay. Um, use sales presentation dashboards. What does this go to? Kaggle. Okay. Okay. Sales data presentation dashboards. Interesting. Provided by LinkedIn Learning. Sales data set. Okay. Hmm. Hmm. So I need to download this. Um, I think it's safe there. I think I'm gonna actually not gonna create like a data folder underneath there. Although maybe I will. I don't know. Yeah. Okay. So there's main code, there's solution, sample solutions to the various exercises, and then source data. I mainly just need the source data. So you're just going to see that appear. There we go. There it is, right there. Okay. Hmm. Probably just fake data um, created with like Faker or something like that. Yeah. But anyway, there it is. Okay, so that's the data we're going to work with, but we'll go over what that is. So how do I want to handle this? I don't want to, so I don't know if I want to work off of the real Python thing or the other part. Oh, why is that like that? That's so weird. Why is the quiz on there twice? Okay, that's just at the end. Well, wait a minute. Yeah, that's the same thing. Get rid of the. There we go. Whew. Brain is all kinds of all over the place right now. I should be wrapping up in a few minutes. I think I'm just going to get started on this, and then tomorrow we're going to do some other. Um, yeah. Hang on a second. Let's go back over to what do we call it? Here. Uh, oh my gosh! Why are we going so far? Stop that! Come back! Come back! Don't go so far. There we go. Okay, so I guess I'll just delete these. Like, I'm not keeping up with this. I'm not doing very good with that. That is a practice I want to take, especially when I'm working through projects, because I want to just kind of get do some problem solving with numbers again, uh, outside of the coding universe. You know, the coding verse. Um, so create pivot tables and Python polars. Uh, that's gonna have to get moved, and then data and sampling distribution is gonna have to get moved to next week, probably. And well, I don't know. I was trying to, yeah, yeah. So weekly review. Should we do the Python thing then, the polars then? Because visualizing should come after. I'm gonna do a dive into that. I don't know if I need to do the NumPy stuff here. I think it might just be more important for me to do whatchamacallit, SQL than to do futzing around with like NumPy stuff. Conditional expressions. I think just the main, maybe it does come in handy when doing some cleaning, but I feel like if we're doing cleaning, we're using pandas, which has the, underneath has that. How old is this article? It is relatively new. Okay, it is. You know what I'm going to do? I'm going to push it back until it is kind of advanced. Like knowing SQL is more important than this, but it is kind of handy to know. So I'm going to move it to St. Patrick's Day. Move it over there. Okay. Weekly review. Got to do a monthly review this weekend. Creating pivot tables with pandas, and then we got to go from that to then. So we're going to do it over 2 days. And then I got to move this to the next day because I don't want to do it on the same day. In fact, I think it would even be better if I moved it to Monday as a break, you know, as a test of knowledge. I think that's what I want to do. Yeah, because I really do want to keep Friday open for working on finding projects, um, and doing the review, recapping everything. Just yeah, right. Okay. Because we are coming up against like that build projects thing. I want to start building projects on the first. Uh, yeah, that sounds good. That sounds good. That sounds like a good plan. Okay, so let's get back to this. Shall we? Shall we get back to this? Gonna use this alongside here. It's kind of weird because I don't know. I need like kind of a third view with my live stream here. And that third view needs to have um, a view of one screen on the right half of the left monitor and then the left half of the right monitor and have those there because that's where I like to look. Um, yeah. Uh, so otherwise I'm looking all the way over here. I'm looking all the way over there. Like it's just a little too much. But anyway. I wonder if anybody's going to pop in today. Haven't gotten anybody. Uh, yeah, well, that's okay. It's fine. Not sure what we're gonna do. Do I like? I don't know if I even want to start this. I think what I want to do is just make sure that I can just import pandas and get to this first thing with how to create your first pivot table. That's probably sounds like a plan, and then I'll wrap up the day. So, a pivot table is a data analysis tool. Allows you to take columns of raw data from a pandas data frame, summarize them, and then analyze the summary data. I might want to actually create pivot tables. So I might want to note on pivot tables. Yeah. um, it's going to be in analytics. And we'll get a definition here. And that's according to real Python, but that's okay. Pivot table. We'll say it's a pivot table is a columns of raw data. Well, um, from a data frame or spreadsheet, we'll say, summarize them, and then analyze the summary data. And actually, can we do like yeah, data frame spreadsheet. So rectangular data could be a spreadsheet as well. Spreadsheets can be messy though. There's no, it's not really structured. Yeah, but anyway, summary data to reveal its insights, and that is and so we'll just do it from there. That'll link it back to there. Good. So I have a definition that I can come back to if I need to review my note on pivot tables. Okay. Oops. Yeah, there we go. My God, I am a messy bitch here. So let's say when a pivot table is useful for performing such as sums, counts, averages, and Okay. So oftentimes, the table produces data, the information or the data. Pivot table produces revealed trends and other observations that the raw data, originally hides. Pivot tables were originally implemented in early spreadsheet packages and are still a commonly used feature of the latest ones. They can also be found in modern database applications and in programming languages. So, I kind of want to do this in LibreOffice as well. Let's have resources for the note, right? You have that. You have okay. Inserting that. So we can do this with LibreOffice. It might be something that I want to practice to recreate what I do with pandas in whatchamacallit. Mm-hmm. See, see,
To extract data from a large data set in LibreOffice Calc, you may have used functions, formulas, or even a VLOOKUP. Well, today I'm going to show you an easier way to extract that data by using a pivot table. Now,
so seems like good content. It's up to date. It's a year ago.
Hi guys,
And then
welcome to this session in.
let's do a filter of last year.
Hi guys.
Oh, there's actually LibreOffice tutorials.
Hi guys, welcome to this this session in
There's one from a month ago.
Hi, in this tutorial we will learn how to create.
Hi there, Wally here. In today's video, we are going to talk about
Being skilled is an interesting one.
Then
Hi guys, welcome to this session in LibreOffice Calc. In this module, I want to talk about
Nice.
concatenate, concat, text join, and then just using the and sign to join text strings together. So first of all,
Problem is it's not updated frequently. Oh, maybe it is 5 days ago. 11 days. Oh, I stand corrected. Can't wait till just little by little, I'm gonna gather some tips and skills and stuff to learn how to use LibreOffice. So, yeah, cool. This is what I want. LibreOffice tutorials. I don't know if they're official.
we are a skill development company focusing on skilling everyone who wants to acquire a new skill. So if you are a keen learner, being skilled,
This one has way too many different things.
abundance of knowledge everywhere on the internet.
So,
Be it the blogs, be it YouTube, the knowledge.
there's a playlist though.
Today I'm using Upwork to hire a WordPress developer. I'm going to try using Upwork AI. It's great that you can just write a couple of sentences and they create the rest of the job description. We went from no job post to ready to post in about 5 minutes, maybe less. I'm so excited to get this project kicked off.
I don't know why that. What is the SI thing? It's not tag, right? What's it called? Source ID? Mm-hmm. What is the point of it, though? Mm. All right. Hmm. Match. Hmm. Author is copyright owner. The fuck? Really? So weird. Okay. I just like collecting things. I don't know why. What? Yoink. Weird. Okay. There we go. Okay. Yeah, I guess I'm gonna come back to this tomorrow. I'm just not feeling it. I really just need to wrap up the day. Um, yeah. What the fuck? Okay. Yeah. Just gonna wrap this up. Okay. Let's do our Jerry Springer thing. Yeah. Weird. Oopsie. $400. There it is. So what did we learn today? New job hunt day. Take me to blue sky. Hmm. Follow me too. Oh, of course. Mm, so dumb. Okay, so that's it for today. um, to recap. Uh, so to recap, Elon Musk did a Nazi salute. The EPA webinar was canceled. We worked through exploring two or more variables with practical statistics for data scientists. Did hexagonal binning and contour plots. Two categorical variables we explored with trying to remember what we did for that. That wasn't the. What did we do for that? I don't remember. I'll have to review that. Was that the hexagonal binning? I think it was. The contours were plotting numeric versus numeric, but hexagonal binning was for categorical variables. categorical and numeric data. We did the box plot, right? Box plots that were conditioned on. We did the example with the airlines, conditioned on which airline, and the delays of the flight delays, right? Daily flight delays. Visualizing multiple variables. Then was what we did for well, how did we do that again? My gosh, my brain is just like information comes in and just leaves. I just do things and then it just sayonara, peace out. No more knowledge. Hmm. Right. I created a like we have this thing, right? That wasn't the thing that we were looking at. Was it what we were looking at? Oh, that was what it was. Yeah, it was facets with the multiple variables. Is that what it was? It had to be. I guess that's what it was. I don't know. My brain's fried. Let's look at the notebook for that again. Yeah, that was the last thing we did was the seaboard and the facet grid. Yeah. Okay. So we created multiple plots based on the zip code to explore some kind of, differences in quality of the data for, given one value of a category, basically. Yeah. So okay. So that does it there. Mm. All right. And then we did how to create pivot tables with pandas. We started doing that. I'm just going to move like all this other stuff into the next day. When I open that up tomorrow. Yeah. So I also have to do the pivot table, right? Did that one. I did create a note for that. Is there anything else I made a note for that I'm forgetting? Let's take a look at. Oh gosh, I keep doing that. I hate this. I don't want this. I don't want the canvas thing up on there. It sucks. Inbox. So there are some things that I did that I didn't, right? So maybe not. Maybe it wasn't. This is just my note on all of my data science notes. Okay. Alrighty. Then that's going to do it for today. Yeah, it's time to stop for today. So, if you're watching this on replay, thanks for watching. Thanks for joining. And please hit subscribe if you like this stuff. If you want to follow me on this journey to get hired in 2025 as I refresh my skills, build some projects, and start connecting with recruiters and getting my name out there, right? Yeah, slowly but surely we're getting there. So,